I'm really pleased and excited to have the opportunity to speak with you today about modern data pipelines. I have a background in the space on the vendor side. I was with Attunity for 5 years until 2020 when I joined Wayne and Eckerson Group. Attunity obviously got bought by Click. And so there's a lot of very interesting dynamics in the data pipeline space that are driving quite a bit of change. And so the way I look at this is that there's been this three-stage evolution of data pipelines. The first phase was what we could call the loading phase, where you have periodic ETL batch loads from relational databases to a data warehouse to support operational reporting, to support operational dashboards. And that was a traditional paradigm. Um, these batches were taking place every day, every week, maybe every hour. And it was a pretty predictable, sometimes clumsy, but usually pretty predictable and unchanging paradigm. In the 2010s, there was a move to consolidate because there was a rise of new types of sources of data where you've got SaaS applications, you've got IoT sensors, you've got social media feeds, all kinds of things are generating new types of data, some of it multi-structured data now. And there was a real desire, enterprises sought to consolidate all that data onto an enterprise data warehouse, increasingly on the cloud, both with batches, with incremental batches, and with streaming technology. And this was to support BI and other types of analytics initiatives, looking at predictive analytics, looking at data science. In my view, the consolidation phase, data consolidation proved to be a bit of a mirage because while organizations can and do consolidate some or even most of their data for analytics onto a given cloud data warehouse, there's a long tail of other data that's going to continue to reside on premises, that's going to be spun off and put into other clouds. And as a result, the reality that we're dealing with now are these heterogeneous, hybrid, multi-cloud environments for most enterprises. If you have an enterprise that was born in 2015, cloud only, that's easier. But most enterprises in the Fortune 5000 are really looking at these hybrid environments, a long tail of data throughout this distributed world, and they're dealing with complex real-time data flows. They need to synchronize that data across multiple points. This can help support all kinds of innovative activity, business intelligence, AI, ML, and merging of analytics with operational workflows in order to generate automated action. So modern pipelines need to synchronize all this real-time data across distributed architectures in order to drive faster, smarter analytics and operations. So what's driving all this? A big market driver is data supply. There's a boom in data supply in terms of volume, variety, and velocity, the three V's that we look at. I talked about some of them already, but I think it's fair to say that as organizations digitally transform themselves and convert to digital platforms for engaging customers, for streamlining their operations and digitizing their operations, they're throwing off all kinds of data from smartphones, from tablets, from IoT sensors, from social media platforms. And that creates a lot of opportunity. On the demand side, there's an explosion in demand because the business, through data democratization, through advanced analytics, through increasingly data-driven operations, really craves a lot of this data. In between, you have data pipelines that are feeling a lot of strain. They're dealing with an explosion in supply, explosion in demand. There's a need for many data pipelines. And sources of strain are not just the big supply, the big demand, but also the fact that business requirements are going to change, requiring new sources, new targets, new pipelines. Bottlenecks inevitably appear and complexity continues to rise. So enterprises are at an interesting phase right now where they're struggling to build and manage the data pipelines that feed modern business. And I think it's fair to say that on any dimension, the data pipeline market continues to change quite a bit because all of the new exciting initiatives, whether it's cloud migration, cloud modernization, data modernization, advanced analytics, generative AI, depend in some fashion on data pipelines. So just looking at these five dimensions, on the adopter side, you have in a sense, two notable camps. The first is the cloud native startups. Now, I'm using the term startups loosely because there are companies that were born in 2015 or later that are now massive, hyperscale. But they're all cloud because they were born in an era in which that was an option. The rest of the camp, the Fortune 2000 or Global 5000, depending on how you look at it, are living in more of a hybrid and multi cloud world. They are moving what they can to the cloud. They're moving what they can to a second cloud in order to optimize certain workloads, take advantage of certain cloud provider tools, and so forth. The priorities include migrating to the cloud, democratizing data access, embracing advanced analytics. Now, users are, there are a number of different users here, and one of the primary themes is collaboration among these personas. And so data engineers have been around for a long time, and they continue to have a deepening of their role. They can continue to have more and more demands put on them by the business and on the IT side. Now you've got analytics engineers as well that kind of exist as a layer between the analysts and the data engineers, data analysts and data scientists as well. Some of the primary use cases here are continuing to scale out adoption of business intelligence. We find that BI tool adoption is relatively flat, but consumption of the output of BI tools continues to widen. There is an acceleration of adoption of machine learning. We all know that there are these rich repositories, these rich libraries with algorithms that you can train into a viable model for your enterprise. And there are just so many ways in which ML can improve the efficiency and the effectiveness of the way you do business. And as well, there's an integration of analytics and operational applications. As a case in point, so many of the machine learning use cases that are compelling are of a real-time nature. You want to take immediate action based on the outputs. On the tool side, data engineers continue to increase the number of tools they have, and they're also experimenting with generative AI. We had some pretty interesting findings in some informal LinkedIn polls. Most data engineers expect to increase the number of tools they use to manage their data pipelines in 2023 compared to 2022, despite the opportunity for tool consolidation. And a significant chunk of them already are experimenting with ChatGPT or other types of generative AI to improve productivity. So on every dimension, the data pipeline market continues to change. Okay, we could spend a lot of time on this slide. I probably won't spend too much. What is a data pipeline? Put simply, it moves data and transforms it from a source to a target. So there's the ingestion phase, which can involve extraction, capturing a live event, streaming that event to a target. It'll involve loading it, maybe a batch load, maybe an incremental batch or a bulk load. You can append data or merge it with a target. Transformation is critical. Transformation might take place during flight in an ETL pattern. It might take place more commonly now in an ELT pattern where you've got transformation taking place on the target. So common transformation functions include filtering of data, combining or merging data sets, formatting or reformatting, applying a structure to it, applying a schema, evolving that structure based on what's happening on the source, and then cleansing it, removing duplicates or validating that data. Now, this can apply to structured data existing in rows and columns. It could apply to semi-structured data, maybe objects that have simple tags on them, or fully unstructured data. In all these ways, you've got to ingest data and transform it in some fashion for analytics. It applies to schemas and metadata, other types of metadata as well. So all this exists on premises, in hybrid environments, in cloud, and increasingly in multi-cloud environments. There's a pretty rich software ecosystem that we're talking about here. The patterns are not just ETL anymore. They're also ELT, ETLT, reverse ETL, where you're operationalizing data from the data warehouse to activate, for example, digital ad platforms or other applications. There are a polyglot set of languages here. A lot of active open source projects. Spark plays a big role in pipelines these days, as does Kafka, and a lot of commercial tools have started to standardize on Spark, Kafka, GitHub, the DBT open source project, and DBT as a company is taking hold in a big way. So there's a lot going on here. And the other thing I'll just put an exclamation point on are the AI bots. ChatGPT, as I mentioned before, has a significant chunk of data engineers already experimenting with it. And I think there'll be more of that it doesn't reduce the expertise required, but it can potentially improve the productivity because you can have people that, if they inspect the outputs of ChatGPT, can use it to write documentation, can use it to build starter code, they can use it to debug pipeline code, and so forth. So in sum, there's a rich ecosystem. Modern data pipelines comprise a lot of functions and draw from a very rich ecosystem of capabilities. And they need to, because you've got a proliferation of users, use cases, projects and initiatives, devices, um, analytical tools, and then applications and platforms. So there's a lot going on in a given enterprise environment or startup environment, such that you need pipelines to dynamically tie together data flows across databases, analytics platforms, applications, and BI and data science tools. It's fair to say that enterprises are going to continue to add elements to their heterogeneous data architectures. We live in very interesting times. So this all creates a very interesting backdrop, I think, for the data pipeline tools that we'll be looking at in the tool categories that we're looking at. So how do we define this market? Modern data pipelines have a few critical, what I see as 4 critical market segments, and I'll work from the bottom up in this diagram. The first important note is that we're looking at on-premises systems. We're looking at traditional mainframe systems, which persist on many environments, iSeries, SAP systems. A lot of operational systems continue to reside on premises. But that data, in many cases, needs to be synchronized with analytics targets in the cloud. And so that creates a hybrid paradigm. There are also new cloud environments that even large enterprises are standardizing on for a new business unit, a new project. They'll go cloud first, they'll go cloud only, and they'll also go multi-cloud. And the reason they'll go multi-cloud is in order to avoid too much dependence on a given cloud provider platform. They'll do it in order to gain negotiating leverage with these cloud providers. They'll do it in order to optimize pricing or availability SLAs in different geographies. And they'll also do it because certain cloud providers have analytics tools that are more appropriate for their use case, or they foster an ecosystem that's more appropriate for their data science or the BI teams. We talked before about the increasingly multi-structured nature of this data and the schemas and the metadata associated with those data flows. The ingestion piece is the market of tools that focus on data extraction and loading from source to target. Transformation, as we talked about, is filtering and merging and formatting data for consumption. Now, data ops is a critical segment here that exists as sort of an umbrella construct. This is a discipline that's increasingly well established for optimizing pipelines using continuous integration and continuous delivery of pipeline code, testing of that pipeline code, monitoring of it. Data ops also includes or is a close cousin of observability. And observability refers to the monitoring and the optimization of data pipeline performance, the monitoring and the optimization of data quality. So there's a whole class of tools that address data ops either as standalones or as part of a suite offering. We're going to talk more about what that market really looks like. The final note here is orchestration. Orchestration, also a cousin of data ops, but it's critical for organizations to look at how they're scheduling and executing, monitoring, adapting, and optimizing workflows, sequences of tasks that stitch together data pipelines and the applications, whether it's analytical tools or operational applications that consume the output of pipelines. So data pipeline management comprises these 4 segments: data ingestion, data transformation, data ops, and data orchestration. Okay, it's more than tools. We all know this. People and process need ample attention for success. And so the way I've sort of divided up the success factors here is to group it into three stages. There's design of data pipelines, operation, and then adaptation. The first principle or success factor for effective design of data pipelines is to align with business priorities. It's critical and it's a cliche, but always worth restating because um, with the best of intentions, enterprises forget this. You need to start with what the business requirements are, go to the business owners, get executive endorsement, and from that, build out your use cases. Maybe you have a desire to improve cross selling for a given business unit on your e commerce website. Maybe you have a desire to improve operational efficiency and reduce downtime with your fleet of delivery trucks. There are a lot of very specific business priorities that need to guide everything that happens thereafter. Another important principle of design is scoping not just current but future requirements. Um, During my time at Attunity, we found that a lot of organizations were interested in standardizing on tools that could handle a whole set of sources and a whole set of targets, some of which they didn't even have yet. So they wanted to future proof, if you'll permit the term, what they had, because they understood that they have dynamic protein environments that will change, and they wanted to make the pipeline tools a constant factor so that they could spin up new pipelines and adapt them as they saw fit. Embracing graphical tools is critical. There are many data engineers, I'm sure there are plenty of practitioners and leaders on this call that will prefer the command line interface to handle custom work, to handle specialized transformation tasks, and so forth. But most folks now recognize that they need to reduce the time spent on repetitive, error-prone tactical stuff, and graphical tools can help quite a bit. Graphical tools also, a graphical user interface and a no-code, low-code approach can help democratize data access so that business-oriented analysts and so forth can actually roll up their sleeves and get into data preparation themselves. When we look at operation, there are a couple of key principles here that are very closely related. First is automation, putting automated processes in place as you schedule and configure and schedule and monitor workflows, as you automate monitoring and alerting. All these things can help improve efficiency and the productivity of your data engineering teams. This aligns closely with standardization of elements. It's critical to reuse, to standardize certain elements so that you can view your pipeline artifacts as Legos that can be used interchangeably in a modular fashion. This greatly improves productivity while still enabling data managers and data consumers to reassemble components and meet their specialized requirements of the moment. Adaptation. At the outset and throughout the process, or enterprises and data engineering teams need to monitor the technical and the business key performance indicators. They need to make sure that the latency, the throughput, the concurrency, the uptime of their pipelines meets their SLAs. They also need to make sure that they're delivering the right data to the business to support machine learning models, to support business intelligence reports, and so forth. And so those business and technical KPIs can really help guide data engineering teams as they need to adapt their data pipelines. Optimizing quality and performance is a critical element here, and a lot of this gets to looking at the quality of data, validating the accuracy of that data, and making sure that the pipelines are delivering the data on time and responding to red flags that are rising from the KPIs. We talked about reusing modules, and that's going to support making modular changes to your pipelines. So successful data pipelines are going to depend on effective design, operation, and adaptation. The benefits: if you do it right, you can build a circulatory system that really drives a healthy business. Uh, Data consumers and businesses can derive more value from their analytics because the data is timely and accurate. They can meet changing business requirements. It's fair to say that 2023 is off to a big start in terms of competitive dynamics. You've got this embracing of generative AI. You've got continued geopolitical uncertainty. There are a lot of big changes in the business environment that need fast adaptation in terms of consumption of data. Data uptime and reduced risk are a major benefit. Organizations, as we know, are more and more dependent on data, on timely, accurate data. And if you can improve your ability and your confidence to meet SLAs, you can reduce your operational risk. And efficiency, what I'll say about productivity is that data engineers have a lot of hats they're wearing right now. They are a busy, in-demand bunch. And taking advantage of automation tools, taking advantage of AI bots can be very helpful. There's no question that ChatGPT does not reduce the expertise required, in my view, for data engineering and for creating pipelines, because you still need to very much inspect the outputs. However, it can reduce the time you spend building documentation, debugging pipelines, and so forth. Okay, so in terms of wrapping up the best practices here, I encourage organizations to treat data pipelines as a living, adaptable organ or contributor to your business. As with everything, you can't go from point A to point B and completely change your business. You need to make incremental changes. So look for a quick win in terms of adapting how you manage and deploy pipelines. Look for a beachhead of success to gain executive support, and then start to adapt other parts of your environment. So don't rip and replace tools or processes, but rather look for incremental change. And final point here, define your tool evaluation criteria based on business objectives. It's important not to start with science experiments. Start from the top, start from the top line or the bottom line business objective and work from there. So if you take an agile, incremental, and business-centered approach, you can really modernize data pipelines to meet that explosion of demand and explosion of supply that I talked about earlier. Okay, so what I want to do now is go to Jennifer and Ranajay, and we will talk about what they're doing in their environments. Okay, Jennifer and Ranajay, thank you both for joining.
Thank you.
Why don't I let you both introduce yourselves and your roles and responsibilities. Jennifer, why don't you go first?
Sure. I'm Jennifer Ochberger. I'm the Director of Data Engineering here at Quote Wizard, which is a division of LendingTree. I've been in this position for about a year and a half now.
Excellent.
So, yeah.
Jennifer, do you want to talk briefly about your background?
Sure. I've been a data practitioner for over 20 years. I've done the role of the data engineer building the data pipelines. I've been a data architect, actually started here at this company as data architect and then moved into the director of data engineering position to sort of better align all of our teams and get things going better. So I've had a lot of experience with data pipelines.
Okay, very good. And Jennifer is also a two-time colleague or coworker of Jay Piscineri, who is another analyst with our team. So Jennifer, thank you for joining.
Of course.
Ranajay, perhaps you can introduce yourself and your role with Citizen Watch Group.
Sure. Everybody, this is Ranajay. I'm the VP of Analytics for Citizen Watch Group. So my role, and I'm in this role for the last 2 years, and I've been tasked to kind of build the analytics practice here. So I kind of work across pillars of data engineering, analytics, and adoption. So all three are very important for me. I have been, for 20 years, I've been working along with data. Initially was like real data engineer, primitive data engineer, where everything needs to be written in code. From that, I've kind of transformed myself to more of analytics and data science area. But I think that data pipelining and the, clean data is the essence of everything, the success. So.
Agree. So very good. So I want to learn a little bit more about both your team's objectives and the role that data pipelines play in that. And Ranajay, perhaps I'll start with you, given your statement, which I agree with, that data pipelines are a critical underpinning to everything. But if you start with sort of the business objectives for Citizen Watch Group, your team's objectives, and then from that, the pipelines that support it, maybe you could talk about how all those elements interplay.
Sure. And I was listening to your keynote, and one thing that you talked as best practice at the end is we need to define our goals by business objectives. I mean, the business goals or the targets. And I think I'm a big supporter and practitioner of that. So I put myself as a target to achieve business goals, not analytics goals in general. So my goal is to get data insights into the business process. So to do that, we have a lot of analytics tools today. We have the dashboards, we have the ML solutions, we have like pure diagnostic analysts as well. And what all of them need is a single source of clean data which can be built with a lot of speed and agility, so that we do not need to wait for a whole infrastructure to be built before delivering any value to the business. So right now my team, the way we started doing it is we went to get the business priorities, started building the analytics solution and the pipeline kind of in parallel. As soon as some pipeline is being built, we start generating value out from there, and place it in front of business. So with that agile mindset and with that agile process being placed together, I think we get some better success rather than waiting for the whole infrastructure to be built for last couple of years or something like that. So that is how data pipeline is that important. And also one more thing I kind of do in my team is when we are talking about people who are building analytics solutions, people who are driving business adoptions, they need to trust the data, and the ownership completely belongs to the team of data engineers who are building these data pipelines. I do not want my analysts to go back and validate every data that have been generated from there. So the ownership remains with the data engineers, and that is very important for my team to have success.
Okay, excellent. And so, Jennifer, I'll put the same question to you, and I'd love to hear it in terms of building on Ranajay's comment about ownership of data delivery. I'd also love to hear, I understand that LendingTree is now all cloud, but started with some on-prem systems. So maybe you could talk about that evolution as well.
Yeah, so, well, our team's objectives, we really are focused on getting near real-time data for analytics and operational reports, which is kind of tricky. You don't usually want to stand between real-time and operational, because any delay means lack of trust in the data. Exactly what Ranajay is talking about. That's so critical. So our team, it is all cloud. We're very fortunate. Our migration was, it happened before I got here, so we were already all cloud by the time I got here. But what the migration looked like was essentially a lift and shift, right? We took all of the on-premise things and we put them into virtual machines in the cloud. And then from there, we migrated from the virtual machines into SaaS as much as we could. So we still have a couple of VMs hanging out there that we're looking to retire. But for the most part, everything is a SaaS offering. And that does add some interesting complexities that you were alluding to. But as far as you were saying, like data engineers, they really do have a huge role, because not only are we taking care of the operational and the analytical reporting and making sure that data gets in place, we're also helping to re-architect and modernize that data stack that moved into the cloud that's sitting on a relational database engine. We're definitely working to improve that infrastructure. So we're helping on the operational side, the transactional side as well. So there's a huge demand, and there's a real need for the team to not just do the work, but to help others do the work as well. So we're leveraging a lot of software engineers to get data loaded into Snowflake, for example, by using Snowpipes and having them event their data directly in. So it's definitely a partnership now. And then data engineering is there to sort of make sense of the data once it lands, if that makes sense.
Okay. And so you've got a need for real-time data. Delay erodes trust. You've got a need for collaboration across software developers, data engineers, and other stakeholders. How does that affect your tool selection? Data pipeline tools that you're using, how did you go about selecting those?
So our data pipeline tools, our biggest impetus is Low or no code, we need rapid delivery. Our business changes and evolves so quickly that we have to be able to turn on a dime, right? We might have an initiative and then the next day someone comes in and says, stop all the presses, we're going to do this new thing. So we have to shift where we're focused. And having tools, we actually use Fivetran for getting data from our operational databases into Snowflake for the databases that aren't modernized and using Snowpipes. And then once it's in Snowflake, we're using dbt to do our transformations. And that's a sort of a low code environment that it does all of the merge syntax where you have to insert or update or figure out what the active record is. dbt does that automatically. So you're defining your source query and then it's building all of the mechanics behind the scenes to make it persist into a table, which is lovely. So we're finding those rapid productivity tools are incredibly needed in this arena to support us.
So you've got a need to change sources, change targets, change transformation jobs quickly, and empower people to do that quickly. And so those are some of the key criteria. Okay.
Yeah.
Good. Ranajay, how about you on your end? In terms of the tools you selected and why you selected them?
Very similar to what Jennifer mentioned, but
Okay.
we use Rivery, but we use Snowflake to pull the data from operational systems into analytics. And of course, my team is focused on analytics. We do very few things with operational in general, but I think we are also getting data from our apps, from the websites as well, and from other different sources. I think one, as you mentioned, Jennifer, I think that low or no code is the 100% needed, and particularly I have a smaller engineering team which really cannot pull all the requirements. With a low or no code kind of tool, it really do a very speedy and agile kind of development. I think that is definitely needed. At the same time, a lot of these tools nowadays come with out of box kits, which is connect to very common connections and get kind of prepare the pipeline for you. And I think that is amazing. That really help us to drive some of our initiatives really fast. So we are using that typically with Rivery and Snowflake as a connector, but we have a lot of different sources from Zendesk to our CDP platform to our on-premise SQL Server, operational systems as well. So we have a bunch of connections there.
Excellent. Okay. So what I'll let you choose who goes first on this one. What's your biggest challenge looking at the balance of this year and next year in terms of helping your teams meet their data engineering objectives?
You can start, Jennifer.
Everyone's being polite. Go ahead. Go ahead, Jennifer.
Our biggest need is really to solve that getting closer to real time. I think we may be focused more on as our sources are moving more unstructured and we're having more unstructured data sources, we're going to lean a little heavier into reporting tools that are going to support unstructured data so that we can have those operational reports from the live system. With the modernization effort that we're doing right now, that makes it possible to have this kind of reporting versus before it would interfere too much with production processes, so we couldn't have that live operational reporting. I think that's going to be like a pressure relief valve for some of the data engineers so that if systems do pause or like take an extra half hour, we don't have everyone from the business calling us up and saying, are we dead in the water or is reporting behind? We don't want to answer that question anymore. So that's really our biggest need, is to get that real-time ship shape.
Okay, Ranajay.
So for us this year, the focus is more on advancing our analytics journey. So we are doing a little bit of ML solutions right now with a lot more focus on descriptive and diagnostic analytics. And this year we are focusing more towards predictive and prescriptive. So that kind of comes up with a very different kind of challenge with data pipelining and engineering as well. You need data for real time for sure. You need data from very different sources, which is completely unstructured, sometimes trusted as well as very well structured. So that becomes a challenge as well. And at the same time, what we want to do is to so we have currently a pipeline built into our BI dashboards. We wanted to do that more efficiently. I think there is a lot of inefficiency in that process still, so that we are having a very high computation, cost for some reason. There are some areas where we do customization, which is not really efficient, I think, and that where the cost is really high. So we need to make sure that to minimize the cost and just balance the storage and computation area. And that I think is heavily dependent on the data pipelining team and the data engineering team as well.
Fantastic. Yeah, we're doing related research on FinOps, this discipline, and the creation of FinOps programs that can help govern cloud-related costs. That cloud compute can create a lot of pain at the end of the month, and it sounds like that's something that you're starting to look at as kind of a core principle of data engineering.
True. Yes, very much.
Very good. Well, Jennifer and Ranajay, I really appreciate you joining. This was helpful. We find our community really enjoys learning from their peers and their best practices. So sharing your expertise has been very helpful for us. So great stuff.
Thank you.
Yeah, thank you.
Okay, thank you. So what I'm going to do now is share my screen. I'm going to share a few more slides about the landscape of tools. And then I will hand back to Wayne for the next segment here. Okay. So hopefully folks are looking at my slides, and I'm not seeing messages that indicate my audio is giving us trouble. So it looks like we've stayed in the right place there. All right. Tool ecosystem. We all know and heard from Jennifer and Ranajay that data pipelines are part of a larger story. Not surprisingly, data pipeline tools are also part of a larger story. So we talked about data pipeline management segments, including ingestion, transformation, data ops, CI/CD testing, operationalization of pipelines, and then orchestration of those pipelines with each other, as well as the applications that consume their outputs. Data pipelines coexist with, and depending on the vendor, integrate with other aspects of data management that might include governance platforms that help create and enforce and police policies about data creation, management, and consumption to reduce compliance risk, to improve accuracy, and so forth. They also integrate with and coexist with data catalogs, which will provide a view into all the data assets in your organization. And data fabric and data mesh both depend on, and in fact, depending on the approach or the platform you're looking at, include data pipeline functionality. There's also a lot of integration on the application side. Business intelligence. There are business intelligence platforms such as Tableau or others that are now reaching down into data integration. Qlik, as we know, acquired Attunity in order to provide not just the BI layer, but the data pipeline layer. Artificial intelligence and machine learning applications are also consuming the outputs of pipelines, and in fact offering some of that functionality for data scientists who want to help prepare data. And workflow management. This includes tools like Airflow, which will help orchestrate not just the pipelines, but the applications. So you should really treat data pipeline tools as part of a larger ecosystem for your data and your application environment. There are specialty tools that are applying within it, one or two segments, and then there are broader vendors that are applying tools across segments. So on that point, I have a few example tools here, I think there are 15, and there are certainly probably 10 or 15 more that are worth profiling here. I won't go through this line by line, but this is in alphabetical order so as not to show preference. I'll point out a couple things that if you look at Astronomer, that's packaging and supporting Airflow, which has become somewhat of a standard when it comes to workflow orchestration. Coalesce provides the ability to visualize and speed up complex transformations at high scale and make pipelines extensible for Snowflake environments. DataOps.live, we have the DataOps.live live team here today, is offering data ingestion, transformation, helping orchestrate pipelines, and providing data ops capabilities, as well as a control layer for common third-party tools, Fivetran or others. dbt, we've talked about a fair amount already, as well as Fivetran. Fivetran is here today. Fivetran is gained a lot of traction, not just for connecting pipelines, connecting data across on-premises environments, but also in the cloud. We'll move on here. Nexla is also here today, and I'll let them talk about what they have in terms of providing a suite of capabilities to operationalize data products, and Rivery as well, which is providing a suite of capabilities to assist data engineers and analysts at hybrid or, in many cases, cloud-only enterprises. So the key point here is this is a very rich ecosystem, and it's not easy to make sense of which tools to categorize, evaluate, and select. We have taken our cut at this. We've put things into a few buckets. So I'll start with the columns here. The cloud focus is, you can view that as kind of a spectrum. This is not to say cloud only or hybrid only, rather the degree of focus on cloud and the degree of focus on hybrid environments. So if you start at the top, there are suite products that address all four of our market categories: ingestion, transformation, data ops, and pipeline orchestration. There are suite capabilities for cloud environments. There are also suite tools for hybrid environments. And in a lot of cases, those vendors are providing integration with that long tail of operational data that remains on premises. Specialty tools similarly divide up into a cloud focus or hybrid focus. And the specialty tools are looking at focusing on a specific 1, 2, or maybe 3 segments of the data pipeline market. So transformation, DBT, ingestion, Fivetran, although they're also integrating in a big way with DBT. So there are specialty tools that are helping focus on specific aspects of data pipeline management for cloud environments. There are also specialty tools that are focusing on specific segments for hybrid environments. So this is how we see vendors breaking up into these categories. And there are a lot of next steps in terms of evaluation criteria. I have another slide on this, but this is one way to start categorizing the vendors and the options that you have at your disposal. I would encourage everyone to learn more about these tools and get into a proof of concept and so forth in order to make sure they're making the right selection. But one of the first questions you want to ask as a data engineering leader is to say, to what degree am I focused on the cloud? How much am I worried about the material, the data that remains on premises? And then to what degree do I need a specialty tool because I have deep capabilities that are required in certain areas? Or can we afford to, is there an advantage to going broad with a suite? All right, so I want to conclude this segment by looking at challenges and product evaluation criteria. The challenges underscore some of the trends we've been talking about for the last hour. There are rising data volumes. There's a rising data velocity and variety as well. And that's put a ton of pressure on data engineers. There's also an increasing focus on the perishable value of data. Real-time events need real-time attention. Just to look at some of the common use cases for machine learning that are getting operationalized right now: fraud detection, customer recommendations, web content personalization, IoT preventive maintenance. Those are things that can't wait. There's a window of opportunity, and depending on whether you define real time in terms of milliseconds or minutes, we're talking about prompt action. And that's a challenge. Complex coding continues to be a challenge, as are these complex environments, and certainly compliance risk, which I believe will only go up in the wake of rapid adoption of generative AI tools, just as an example. So the evaluation criteria that this results in there are 5 buckets here. First is the breadth of functionality. Are you looking at a tool, a product that can help you address all the key functions that you need, or might you need multiple tools? Performance and scale. Latency and throughput are critical. Concurrency is also critical for certain applications. And that often happens when you've got rich operational data running on a mainframe on premises. You want to synchronize that real time to a cloud. Performance starts to matter. Ease of use is critical. Ease of use is a bucket that can start to bring together both automation, graphical interfaces, and AI assistance. Open architecture. I think open architecture is really table stakes, and I'm not sure there are a lot of tools out there that are falling short on this one. This means you need to integrate with the huge ecosystem of commercial and open source elements. And then governance. Data pipeline tools are not governance tools, but they need to contribute to a governance policy. And they need to do so, for example, with role-based access controls, with authentication of users, with authorization of what they do. If they can inspect and observe data quality, all the better. So you really need to review and select your products based on their ability to address your highest priority challenges. So let's get started. Thank you everyone for joining. This, I think, will be particularly fun and educational. We have Justin Mullen, who is CEO and co-founder of DataOps.live. Justin is coming in from London. Mark Vandewiel, who is the field CTO with Fivetran and came on board. I think Mark was you can correct me, Mark, a co-founder of HVR, which Fivetran acquired. We have Saket Saram, who is CEO and co-founder of Nexla, and Taylor McGrath, who VP of Solutions Engineering at Rivery, and also Mike Pickett, VP of Growth at StreamSets. So a lot of folks here, a lot of expertise, not enough time, but let's dig in here. And I want to start with Mark. Mark, maybe you could tell us, you're with HVR and Fivetran, both started about a decade ago. And I would love your perspective on how the challenges facing data engineering teams have evolved over the last decade.
Yeah, thanks, Kevin. That is a great question, and it's actually been a very exciting journey from my perspective. Now, I do want to correct, I was not one of the co-founders of HVR. I was one of the very early employees, and I was the first employee based in the United States, but I was not one of the co-founders. Now, in 2012, so with HVR, I was with HVR at the time. We saw very little cloud at that time, right? Like at the time, people were doing on-premise environments, and we saw a lot of data integration opportunities there. With Fivetran, you have to realize that we were founded in 2012, but we didn't find product market fit until 2015. And then with Fivetran, we kind of rode the wave. First, like AWS Redshift became the initial destination, and we saw adoption with HVR on that side as well. And then, of course, then Snowflake and Databricks, like the other cloud platforms, became highly popular, BigQuery, et cetera. Now, where do I see how we evolved here is, I think, first of all, there's more fragmentation in data sources today than there was even back in 2012. So people start using more SaaS applications for unique use cases, whether it's HR or expenses or different marketing tools, etc. Coming from the HR side, we saw an increase in volume, like I think possibly an order of magnitude more data changes today than we saw in 2012. And then the last challenge that I think we deal with now as data practitioners is the how can we manage self-service? So how can we enable our analysts so that, let's say, as a data engineer or even as the IT team, we're no longer the bottleneck. We enable these teams to start servicing themselves.
Great stuff. Okay, so thank you. And so Mike, let's rotate to you. I'd love to understand from your perspective at StreamSets more about the challenges of managing data pipelines across hybrid and multi-cloud environments.
Yeah.
If we could all start tomorrow fresh on the cloud, great. Most enterprises don't have that luxury, and I would love to hear your thoughts.
Definitely. It is exciting hearing a lot of companies these days talk about they are all in on the cloud, and that is fantastic. But data gravity, there still is a huge amount, especially in the larger enterprises, and that's just going to be a process. And I would say we've gone through the fast part of it, and now is the more challenging as companies kind of start looking deeper and deeper into their data sources. And the challenges that we see, and we help companies address, it's first, it's secure access. We work with a lot of companies in regulated industries, so securing the data and managing and not ever letting control go of their data. It needs to stay within their controlled environments. And then from there, we see a lot of companies are, how do I design pipelines that have set logic that I can reuse and redeploy in a scalable environment. And that's one of the things we help companies do, is design pipelines with set logic, set parameters that they can then deploy out to their different business groups that want to, say, access certain systems and use that data in their different analytics. That's slightly on the governance side, but being able to design once and then deploy many. And then seeing the data supply chain is what we call it. Having topologies is how does the data move through the enterprise and the pipelines. That helps companies see what's going on and what are, oftentimes they use it for what are opportunities to take advantage of the data as it moves through, use it for different use cases and such. So, you know, for hybrid environments, the security and managing control, that's really one of the top scenarios.
That makes a lot of sense. And so Taylor, tell us a little bit about how you see customers evaluating the pros and the cons, the trade-offs of a suite approach versus a specialty tool.
Yeah, sure. I think it's a super common assessment you need to make when building, modernizing a data stack. And I think really it comes down to your bottom line as an organization, as a data team. What's most important to you when it comes to data infrastructure? So in today's market, we see a lot of teams who want to do more with less. So less overhead, less management of vendors, less stringing pipelines together from one tool to another. And the ultimate goal of data use cases, is some sort of business value. So meaning that the underlying data architecture or pipeline management is the tool that helps us get to this value or speeds that up. So there's the short term, I think, success metrics of this decision, which is what's going to get us to the quickest time to value for this use case. And the longer term success metrics, like what happens when we have more use cases? What does growth mean for pricing in our budget, in addition to how we're planning to scale our time to value for additional use cases? So I think there's a lot to think about when we're thinking about data infrastructure. Firstly, does it make sense to buy a separate tool for each data functionality, like ingestion, transformation, orchestration, monitoring? The list goes on. Now there's reverse ETL and data activation, or can we do more with less? And I think a feature forward mindset is what ends up hurting us sometimes as technologists, because we are very quick to jump to the perfect technical solution and build all the architecture diagrams that we see as best practice before we understand what the real business problem, the real bottom line is for our use case, which for many teams these days and in this market is time to value and doing that with less.
Very interesting. Yeah, and there's always the classic trade-off of solving a near-term problem now and not creating technical debt with your decision today about what your future options are, not painting yourself in a corner. So Saket, your perspective at Nextla, there's a lot of talk about data products, oftentimes in the context of a data mesh, this architectural approach embracing distributed environments in which domain owners present their data as a product to the rest of the business. I'd love to hear your perspective on a data product, what it is, and what it means to a data pipeline or a data engineering team.
Yeah, thanks, Kevin. So, everything that all of us here are doing is ultimately in the service of the data user. How can everyone become a data user and every data user get ready to use data? Whether it's someone in HR analyzing compensation in a spreadsheet, or you're forecasting sales in CRM, or we are visualizing a marketing campaign performance, in a BI tool. So, data product is that entity of ready to use data for the data user that is trusted, that is validated, that is discoverable, and most importantly, it's consumable by the data user wherever they want to consume it in any tool, right? So the best way to understand data product, I think, is to just take an analogy with any product that we know of, right? So I'll give an analogy with shoes, for example. So products are made with raw materials. For shoes, it's fabric and leather. For data products, it's the data, the metadata, the descriptions, the validations that feed into sort of the raw materials for data product, right? And I want to clarify here that data itself is a raw material and not the data product itself. So, all these descriptions, annotations, collaboration capabilities are part of the data product, okay? Now, someone produces a product as a data product, for example, for a particular purpose. The shoes, it's like, I need road biking shoes. So somebody produces, I can go find it. I can see the reviews. I can get it and use it. And the same thing goes up, applies for data products as well, is that it becomes easier for the data consumer to find and use the product, right? Now, in terms of pros and cons, I would say that I think it's way more collaborative, way more easy, way more, I would say, in line with the goal of data democratization to work with data products. And in terms of the cons, I would say that, not a whole lot, especially if you do it right. For example, we look at data products as logical data products. Instead of making new copies of data, these data products just, sit out there until somebody wants to use it, and then they know where to give the data out in the right sort of speed or format, right? So I think, to your last point, like, why am I talking data products in a pipeline discussion, right? If for a minute, we forget the traditional approach to pipelines and integration, and we just think about a data product centric view, then connecting to a data system and auto-generating a data product, for example, is no different from the capital E, which is extraction of data, okay? Deriving data products from existing data products is very much like transforming data, and then consuming the data product is very much like the L, okay? The benefit, of course, is that this becomes a much more composable way of thinking about things and working with data. And when you have logical products, it means that your underlying data flow can be batch, can be streaming, can be real time. So you have really decoupled the thought process about what happens with data and how it gets used from how this gets executed. So I think it's a very powerful approach to entire data management.
So Justin, I know that there's a lot that DataOps.live does with the creation, management, optimization of data products. Perhaps you could help us frame a lot of the topics we're talking about here in terms of evolving requirements in what is a data ops program, and how does that help meet some of these evolving business requirements?
Yeah, I think there's a couple of ways, Kevin. There's the data requirements themselves in modern enterprises, and there's the business requirements. The data requirements being sort of those data obligations that you've got around security and governance and control. There's the business requirements around meeting stakeholder requirements and delivery expectations, and frankly, cost. Doing more with less. And I think in this regard, the whole discipline of data ops has been sort of a seismic change in the whole data world. And whenever I'm talking about data ops, I'm talking about true data ops. That 20-year battle-hardened discipline that we've had in the software world around DevOps, and bringing that into the data world and changing it. So I think, in looking at those two areas, the business requirements and the data requirements, I think if you look at data ops and, what it's done and what it's doing for, both the discipline and the tooling, for modern data enterprise, it's providing them with the ability to, build data products better and faster, to have a better and a faster developer experience, giving them the frameworks to build faster. It's helping data product teams to parallelize across many developers, making changes to make sure that they don't step on each other's toes. It's finally bringing in the holy grail of automated regression testing, where we're putting tests as core elements as part of pipelines, and in the same way we've done with software for years, and ensure that our business stakeholders are not our testers. And that point that Taylor said about reducing costs, we all want to do more with less. We need efficiency. Our resources are most expensive. So, data ops is really helping enterprises delivering that. But also in those data requirements, which is less about the agility and the productivity, it's more about your obligations around data. Then it's providing a lot of the methods to control the building of those products and those new pipelines and those data products, and the change process around that, the methods to enforce security and who's got access to what the data platform, and of course the audit trail around everything, to basically to be able to prove that you're meeting your obligations. And I think that's what data ops is bringing to modern enterprises today. It's sort of both the discipline and the tooling is bringing that balance of agility and productivity to deliver on needs of stakeholders, and the governance and control to deliver on your obligations.
So Justin, let's add to that the notion of orchestration. I know that you've looked a lot at orchestration of pipelines and of third-party tools to manage a lot of these processes. what would you say are the key criteria that folks should evaluate when they're evaluating tools as it comes to orchestration of pipelines, of artifacts, and how they work with applications?
Yeah, it's a great question. Orchestration is critical, as you say, Kevin, because organizations need a control plane across all of their data pipelines, and that means a control plane that sort of spans all elements of a data pipeline and all tools. And so I think when you're looking at this areas, they're looking at this in terms of capabilities. I think there's two sets of capabilities. There's table stakes, the set of capabilities that any orchestrator should provide. And then there's the extended capabilities. It's an advanced thinking organization that you're dealing with, and you're going to be supported into the future. So I think for table stakes, we are talking about that control plane that orchestrates everything, not just internal functionality of the product. So orchestrating the ingestion elements, whether they're native or whether they're orchestrating Fivetran or Matillion or Azure Data Factory, orchestrating the transformation and modeling elements, the data quality elements, maybe Monte Carlo and Soda, and the data science. So all of those elements are key. Capabilities around a comprehensive logic framework, deciding what to trigger and when, comprehensive scheduling capabilities, being environment aware, because data pipelines need to operate differently in production environments than they do in development environments and vice versa. A hybrid approach, so that they're not just orchestrating in the cloud, they're orchestrating behind firewalls and in the customer's own business, and metadata intelligence, so that the pipelines and the orchestrators are not just telling stuff what to do and when to do it, but they're harvesting back all of the log files, the error files, the telemetry, and all of that data. So that's really table stake for orchestrators. I think when you get into the extended capabilities, then you're really talking about, in fact, some of the stuff that Saket was talking about there. It's areas where you're starting to sort of drive the latest thinking in the data world. Ones that have first-class support for real data products. That understand the need for a data product registry and support data product versioning and all of that. That understand the concepts of backward compatibility and alert you when you publish a new data product that's going to break downstream data products effectively, and understand this whole complex map of data product dependencies and the way that APIs might be dependent on each other. So orchestration is critical. It sounds simple, but it's significantly more complex than many people think. And it's not orchestration just related to whatever you have in your own product.
A lot of instrument players in an orchestra.
Yeah, there is indeed.
Use that analogy.
We use that analogy a lot.
There you go. So Mark, coming to you, if we look at product evaluation criteria for ingestion, what would you say? You talked about evolving criteria or evolving requirements, and I'm sure ecosystem support is critical, as is performance support of a lot of sources and targets. But what would be the top 2 or 3 criteria by which you see enterprises evaluating what they have when it comes to ingestion in particular?
Yeah, so like Justin, I'll start with the table stakes, right? And this goes back to something Mike also alluded to. It's security, right? The platform has to be secure, and that is, again, table stakes. And then another aspect, which I consider table stakes, is the reliability of the platform, right? We build these data pipelines, they better work, right? So that is an incredibly important requirement. And again, I think it's table stakes, but in practice, it turns out that data pipelines break all the time, and that is sad to see. So now going over then to the evaluation criteria, agree with Taylor, right? The organizations want a single technology to address all their data sources, and with the multitude of those, source support, just the variety of sources we can support is I think the number 1 criteria. The second one is related to timeliness. Do we need the data real time? You talked in the keynote, it came up, Kevin, what are the business requirements, right? But from a timeliness perspective, you always want your data as timely as possible. And then the last one that I nominate here is just the total cost of ownership. And that does go back to the reliability of the pipelines, because ultimately, if if the pipeline is not available, first of all, it's not useful, but secondly, like what are the processes to then go address it, and what is the cost of those? So those are my top 3 criteria: source support, timeliness, and total cost of ownership.
Okay, great stuff. And so, Saket, I'll put the question to you in terms of evaluation criteria and the degree to which you need multimodal support. There are a lot of flavors, a lot of sequences: ETL, ELT, reverse ETL, ETLT. I'm sure there are others. But what does that mean to evaluation criteria? My thought is enterprises need to be ready to support a lot or all of these to meet different requirements over time. But we'd love to hear your thoughts.
Yeah, no, we've worked with some of the biggest enterprises out there, like JP Morgan and Johnson and Johnson, right? And they need all sorts of mechanisms. So I think from an enterprise perspective, on one hand, it looks like you need so many tools, one for each type of use case. But then if you really put thought from a technical perspective, data is going from point A to point B and at different velocities. That's all that is happening. And what you have is a different tool for everything. You go from a SaaS service to a warehouse is one tool, and from a warehouse back to a SaaS service is another tool. So I think when you think about the enterprise, they are definitely have concern that what is happening, if you look at the timeline, is right. Generation 1 was tools that was built for IT, and then came the generation 2, the modern data stack, I think, which was a no-code facade on top of the same set of tools. The challenge for the enterprise then becomes, the Gen 2 tools have been great. I mean, they have brought a lot of simplicity out there, right? But it is also like having basically a faster horse. And from the perspective of scalability, more data, more systems, more people, and sustainability of the strategy for the enterprise I think is one that's driving towards the edge of a cliff. So I think that what is happening is a Gen 3 on the horizon, what you, I think, mentioned as this multimodal sort of approach, and it's leading into tools that can really handle all of these use cases, move data from different systems to different systems with a lot of flexibility and ease. And I think, if you ask me, I think this is coming to the iPhone moment for the data tools, where instead of a Motorola and a Garmin and a BlackBerry and an iPod and a Nikon, each of them claiming to be best of breed, you get an iPhone which actually does all of these and better than any of them, right? And I think that's where we're heading into, is saying, let's take a new approach to solving the same problems. And actually, it can be done better. There's a lot of mature stack under the hood in terms of cloud and different technologies. And I think that's where we're headed. So I think enterprises are really looking at all of these things. Like, for example, Mark said, more connectors, they can now be auto-generated, okay? It is more collaboration. Yes, those data products are coming and helping, right? Multi-speed, yes, that is also happening. So, and total cost of ownership really, really comes down when you can converge many of these use cases into the same tool, same learning pattern, same no-code interface, just different sort of systems. And it's the people cost that's the highest when you have to deal with so much fragmentation. So I think that's where it's headed, in my opinion.
Fantastic. Okay. So Taylor, I'd love to hear your thought, your perspective. Rivery's doing a lot for cloud environments in particular, like others on the call, but what are some of the ways in which cloud-only environments or cloud-first environments start to reshape what the evaluation criteria are for data pipeline tools?
Yeah, I mean, I think, before the cloud and everything was on-premise, which meant everything was custom code or having some legacy ETL software installed on an on-premise server, you'd quickly run into limits of scale, and your kind of main requirements really centered around kind of some of the total cost of ownership items, like Mark mentioned, in terms of reliability, et cetera. And with the cloud, it became a bit easier. Hardware could be quote unquote rented from cloud vendors for pipelines to be built on and software to run on. But there's still issues of scale when it comes to being automatic and aligning budgets with needs. So scaling to fit some need on demand, and then have kind of what I'm charged or the price model correlate directly with like the value that I'm consuming. So I think that's where SaaS pipeline tools come in. Where it really kind of takes a lot of those requirements off the shelf in terms of reliability and total cost of ownership. And it just means actually thinking about the parts that, the parts that are custom to you in terms of getting value. So the types of sources you want to connect to, the destinations you have, and similar to kind of echo what Saket said, bringing data from point A to point B or back from B to A, really, it's just kind of these data movements in different shapes and forms. So I think when it comes to deciding on either whether it's like on-premise versus cloud or build versus buy, it's really a decision on what scale and agility means to your organization versus some other concerns of maybe data movement or hyper-customized pipelines. But I think SaaS removes a lot of the requirements that on-premise requires as table stakes, like we mentioned in some of the previous speakers. So I'd say the overall takeaway is that time to value is much quicker with kind of SaaS and cloud only than on-premise, since there's no upper limits to scale, and teams can be much more agile in their delivery of business value.
Great stuff. Thank you, Taylor. And so kind of building on that, you've got cloud environments, multi-cloud, hybrid environments, the need to synchronize data across these heterogeneous environments. And Mike, I'd love your perspective on the notion of data drift. StreamSets, now part of Software AG, was founded about a decade ago. You can correct me on this, with a real focus on, among other things, data drift. And what that means in all its forms. I would argue data drift matters more now because there are things like data drift that changes machine learning model outputs. What is data drift, and what does that mean to the mix here in terms of tool requirements?
Succinctly, shift happens with data. So things change, and that's in a short. It's all the change that happens, and Mark mentioned it, and it's just pipelines break. Well, why do they break? Like the data formats change, metadata changes, schema changes. I mean, that's the one I think most people think of with data drift, and it's very common, and everyone here is able to sense and adapt to that. But it's infrastructure changes. And it's a capability, as we have patents, StreamSets has patents on this, is the ability to sense and automatically adapt to the changes so that the pipelines continue to run, but people are alerted to these changes. And that's another area where we help people understand is like, hey, here's what's changing in your environment. Do you want to do something about that? Is an opportunity to operate differently? And, it's Taylor had mentioned that, you look at on-premise and you're moving into the cloud. On-premise systems, even though people think of them as oftentimes think of them as fairly static, they're not. Those are continually changing too. And as systems are turned off, that's a change, for example. And, you have batch pipelines, you have streaming pipelines. How do you adapt? How do you capture all that? How do you keep your pipelines running through all that change? And that's managing data drift. That's fundamentally what it's about.
Excellent. Okay. We have 5 folks here. You've all been very respectful of each other, which I appreciate. And I will say that if there are things you want to key off one another in terms of comments, we can do that too. This is obviously a conversation too. I do have one final set of questions I can put to folks, but I'll just pause. It looks like we have some questions coming in from the audience, and we're going to handle that during the dedicated Q&A section that will start at 1:15 Eastern. But please keep it coming in. Great. And Saket, thank you already for engaging on some of that. Okay, so why don't we'll go around the horn here, and I'll ask each of you the same question, which is, what differentiates your product in the landscape, and what that means to enterprises? So we'll start alphabetical order. Justin, why don't we start with you?
Sure. So this is the pitch session, right?
This is the pitch session.
We get it out there. Okay, great. Look, I'll kick it off. Look, I think for us, we may differ from some of our other colleagues in a number of areas. I think, first of all, if anyone's looked at us today, we've honed our technology very specifically for Snowflake. So we've got very, very deep integration into Snowflake core functions, into environment automation, how you can sort of build and manage every element of Snowflake in a decorative fashion, and that's very, very unique to us. So that'd be one area. I think a second area would be our North Star is data developer experience, how data developers enjoy it, and as a consequence, how productive they are. So we make a strong play in that. We make data developers as productive as their software counterparts, and we've got a cloud-hosted data development environment that really enables that. I talked about orchestration earlier, and that whole area of automation and orchestration is very key to data upside. And we don't mean just the automation orchestration of what lots of people talk about it, but they talk about it in terms of what they do inside their product. We talk about it in terms of the entire control plane, orchestrating other products that are important, a Talent or a Fivetran or a Matillion within that plane. Similar to Sackett, data products is a core element of data ops.live, so it's a first-class citizen. We support the definition, the metadata about them, the versioning, the dependency maps, and everything. So we're, some of the most advanced capabilities, I would say, in this area. And I think finally, and maybe most importantly, it's that sort of the combination of speed of adoption and being designed to scale. We've got companies like Roche who've adopted us in 4 weeks and now run 50 data teams and 70 data products and are doing up to 200 releases a month. And these are things that we are unheard of in the data world historically. 200 releases a month, most organizations did 1 release a quarter. So I think those would be the main areas that we would feel that highlight our uniqueness.
Great stuff. Okay, Mark, what differentiates Fivetran?
Yeah, so great question, and you'll get my biased opinion. First of all, I think we cover the widest spectrum of data sources, and Kevin, you would understand this because you work with Click at Unity. We compete against the Unity when it's about database replication, and so we see that, and we see Rivery all day, every day when it's related to SaaS applications. But with Fivetran, we can cover that entire spectrum of all the way from SaaS to high volume databases and everything that's in between. So I think that is the first major differentiator. Then we also, with Fivetran, cover different deployment options. So customers can run with the fully managed service, but there's also options to run in the local environment, and even the most security conscious customers can run our software, our technologies completely disconnected from the internet. So look at the spectrum of sources and then the deployment options you have. And then lastly, I would say we integrate really well with adjacent technologies. Of course, Justin, I understand you're built for Snowflake. We integrate with Snowflake as well as a number of other partners. But then we also look at the metadata spectrum with the various data catalog providers. We work with the BI vendors from an integration perspective. We provide data lineage, etc. So 3 things: the variety of sources, the deployment options, and then the integration in the ecosystem.
Excellent. Thank you, Mark. And yes, I agree that supporting the on-prem stuff in particular matters for so many enterprises that will never quite get away from it. Okay, so good. So Saket, you're up next, and maybe you could talk about what differentiates Nexla.
Yeah, Nexla approach, started at the very top of the enterprise land, which is why companies like JP Morgan, Johnson & Johnson, LinkedIn, and DoorDash use us with mission critical data. And it is now bringing that same high quality technology and automation, down to the mass market. So that's where what we're doing right now. I would say the key benefit of Nexla is the same no-code, low-code interface for any type of data integration that you need. So it's a better way of doing that. But then, there are 2 things that happen alongside, and we call it, one is automation and one is collaboration. These are the 2 different approaches to scaling. So one, automation becomes auto-generated connectors, for example. So you're no more limited by, DoorDash, signs up a new merchant, no matter what API, what format, what structure, connected, no code. And then the collaboration, which means that you have those data products that are getting generated automatically. You're doing the integration, but the side effect is data products. They are collaborative. We actually last week launched a private marketplace capability for data products. So any company can create an internal marketplace, have your data products, let people find it and go use that. The last thing I would say about interoperability, which Mark brought up, is essential in the ecosystem. There are so many tools out there. two things that we are doing. One is everything is open in Nextcloud. You can see everything as a JSON manifest. Every single API that my developer team has is available to our users. So that's the other part. And then there's a third component to it, interoperability. So while it is no code, low code for all the data users, it is a complete SDK and command line interface for the engineers. So we are creating collaboration between the engineers and the data users together. So ultimately, I think the only way enterprises scale is when things that they're doing already can be done with automation, greater reliability and simplicity, and it can be done collaboratively, which means more people can participate in that and do the bit that they care about without back and forth dependencies between each other.
Very good. Okay, thank you, Sake. So Taylor, from a Rivery perspective, tell us your pitch.
Yeah. Sure. Yeah, I mean, I think, we operate in a few spaces, so to speak. So covering data ingestion, transformation, and orchestration, and also the pushback of data back to source systems. So I think one is and echoing, I think what a few have already said, but kind of the ease of use with a lot of power. So River users enjoy the no-code, low-code experience throughout all of our native integrations and GUI, but also ask for flexibility as well. So hence why we're API first and offer lots of customizations, like the ability to run like fully managed Python, in addition to the SQL transforms, and connect and push back to any source. So I think it's that kind of marriage of ease of use and robustness and flexibility. And next would be faster delivery and management. So River is a complete SaaS ELT platform. So it gives our customers the ability to go to market faster and have better transparency over their pipeline, end-to-end pipeline statuses and costs, as well as scale faster across multi-tenant environments and ready-to-go templates of pipelines that we call kits. So I'd say, to wrap it up, River is the complete ELT platform that enables data teams to do more with less, so less overhead in less time, and to get to business value quickly and with agility.
Fantastic. Okay, and so Mike, last but not least, StreamSets,
great,
which has interesting touch points with your parent Software AG. Excuse me.
Yeah, and it is great to go last. And I hope folks here is, by the way, is a great panel. You'll hear a lot. We're all platforms, and there is overlapping, but we all do subtly different things. You're going to hear from StreamSets is we are, our unique capability. It is the platform that can do any type of integration, batch streaming, CDC in one environment. So it's same canvas. We do low code, no code, or code, because a lot of people do want to work with custom libraries and bring those into their pipelines. Work with structured, unstructured, and files. I tell folks a lot is files are commonly the lingua franca for how data is passed around the enterprise and even between businesses. We're uniquely able to do that. And then ability to integrate with modern and legacy systems. And this comes in from an asset that we got through our acquisition with Software AG, or Software AG's acquisition of us, is getting to legacy systems like mainframes. And when we look at the broader Software AG capabilities, I'm excited about our future is Software AG has integration of applications, integration of process, integration of IoT, and then we complement that. And I would say it's kind of the final piece is integration of data.
Very good. Okay. I can't resist throwing the firecracker into the midst here of ChatGPT and getting thoughts on what, if anything, it means to your business. We have 3 boys. I have a 16-year-old who loves to give advice to our 9-year-old. And he's kind of like ChatGPT because he'll give cognitively sound advice, but you really need to govern the judgment that he's imparting. And it seems that ChatGPT is similar. It needs a lot of governance, but could improve productivity. I would love to hear thoughts from your perspective based on what data engineers are or are not doing with ChatGPT as it pertains to your product. I'll open it up.
I'll go.
I'm happy to go ahead, Mike.
Yeah, we're saying it's experimental phase, right? I mean, there's a lot of promise, and I think we're still at the we're at the space where people are figuring it out. I was around when the internet hit in the early 90s, and people didn't quite know what to do with it, but everyone had to have a web server. So we're seeing people figure it out. I myself, there are things about it I love. I think you mentioned the best part is folks need to come to it with a ability to assess what it provides back, because it needs to be governed. So that's where we are right now.
Maybe I'll go and address the ChatGPT question in the context of pipelines and our ecosystem. And I think it's a very powerful technology, and I'm super excited about it. And there are many reasons for that. When we talk about no code, we understand that when you have very few controls to keep it easy, you also have to compromise on capability. But there's a reason, a Boeing 737 has so many buttons. It's a complex machinery, and sometimes data is complex, and you can't make it no code entirely. So the ability of generative AI to be able to generate low code from simple descriptions, I think, is fundamentally powerful in what it can enable data users to do without having to be programming. We have been testing some of these things where our ability to generate descriptions about data products from simply consuming the data, and we're seeing that it can be very powerful as well. So there are a lot of things that can be done like that. It also seems like there are some very promising capabilities of ChatGPT and generative AI in general, in terms of how it can make the data much more accessible and approachable to the end user, and simplify the barriers of technology and complexity that keep people away from being able to become data users. So I'm personally pretty excited about what can happen with this.
The only thing sorry, Mark, the only thing I would add on building on what Zach had said is, we're doing a lot of work internally in terms of how we can make the data product developers experience easier and better and quicker. So how, of course, everyone can generate all of these complex statements and everything else, but if we can feed these into generative AI and it takes a lot of the heavy lifting out of doing it, of course, that makes the whole experience a lot better and quicker and whatever. So we've got a lot of work internally going on around how we can embed ChatGPT as a core part of the developer productivity experience. All right, Mark, go ahead.
Yeah, so I'd say from our technology's point of view, we work a lot with structured data, and we work a lot in, let's say, industries where the accuracy of the data truly matters, and some systems need to be like SOC compliant, etc. And there's got to be evidence that even though the data was replicated, that it is actually identical to the source. And from this point of view, Kevin, I second your thought related to your 16-year-old. Like, there's got to be governance, right? Like, and I think certainly for some of these systems where it's structured data and the accuracy is critically important, I don't know that ChatGPT is going to provide a difference anytime soon. However, for more of the unstructured data and where the sheer volume of the data is incredible, to some of what Zach had mentioned, right? Like, that's where I think it's very exciting that we might have a productivity gain here to look forward to.
We live in very interesting times. And I think Wayne is back. This is great. Thank you very much for everyone for thoughtful commentary. It made me a little smarter, so I appreciate that. And I'm sure others on the line agree. Wayne, why don't I hand over to you?
Yeah, great panel, great discussion. Thanks, everyone. So Kevin and I are here to kind of try to pull it all together, synthesize what we heard, what we learned. We'd love to get your input too as well. I'm going to go first, Kevin. From the keynote, your keynote, I took away a few things. One, I think that one of the big themes was that the growing complexity of data environments, more sources on more platforms, more types of data, the 3 V's, volume, velocity, and variety, is certainly finally taking root. And that really increases the complexity of data pipelines exponentially. It's also intrigued by the 4 segments of the data pipeline market you mentioned: ingest, transform, data ops, and orchestration. We certainly see players, even those we had today, like Fivetran, focused on ingest. We know that DBT and Coalesce are focused on transform. We saw DataOps.live today. They're focused on data ops, which kind of envelops all of the data pipeline capabilities and components. And then orchestration. We didn't have any pure play orchestration vendors here, but actually DataOps does that as well.
Yeah, Wayne, I think there are a lot of, there's a good range of tools, and we had a good range of vendors represented here. One of the takeaways I would offer is that 2 ways to segment the market are to say, what's your level of focus on cloud versus hybrid environments? And how sophisticated are your requirements? Do you want to go with a suite or a best of breed tool? So those are 2 of the categories, 2 of the axes that you can use to categorize products and create your shortlist.
Awesome. Okay. I'm looking into the chat right now. So if you guys want to add some things in the chat, please do. I'll be checking it. Let me get back to the slides here. There we go. All right. Also thought, your framework was interesting to compare products by those 4 dimensions suite. In other words, if you're offering more than one of those segments that we talked about, or your specialty focused on one. And then if you're really just focused on supporting the one cloud application, or multiple cloud and on-premises applications like StreamSets, which actually they're really excited by their acquisition by Software AG because it gives them access to mainframes and all these legacy systems, as well as things like process integration and application integration, which kind of takes the whole integration beyond just what we do here in the data space. I thought that was kind of interesting. Got to keep an eye on that, see if that becomes a major trend.
Yeah, absolutely.
All right, let's go the practitioners. Jennifer and Ranajay, good to hear people in the trenches making this stuff work, overcoming the challenges. Jennifer mentioned a lot of interesting things. The need to completely be flexible because the business is changing, and all of a sudden the pipelines they're working on, they got to put to the side while they work on something new and strategic for the company. So I guess that requires a flexible development environment that you can come into and out of pretty quickly. Wow, she really mentioned the need for real time, right? And one reason I was fascinated for that was she said that if people didn't get the data in real time, they didn't trust it as much. That's pretty interesting. And then she mentioned they need to introduce unstructured data, and that's going to change the nature of their pipelines, and the importance of low-code, no-code tools to bring in a whole nother suite of developers. In fact, we kind of glossed over the data engineers versus analytics engineers. But the analytics engineers are really just hyper-focused on building out these pipelines as opposed to doing any infrastructure work. And supposedly you could make some business users, data-savvy business users with a low-code interface do those transforms. Would you agree with that, Kevin?
Yeah, I think there's definitely a movement to empower folks that are more business-oriented and don't have the technical skills, but do want to roll up their sleeves and start to prepare data for analytics. So there's definitely a movement afoot in that regard.
Awesome. Okay. Ranajay, he mentioned the importance of managing costs. And that came out in the panel as well. When we moved from ETL to ELT, leverage the processing power of databases for doing transformations. That's great. Better engines, bigger, faster engines, but the costs skyrocket if you're not managing those processes in a prescriptive way. So I think we're seeing a lot of emphasis, as you said, Kevin, on FinOps, which is how do we manage cloud costs and keep them from skyrocketing. He also mentioned that you need to move to prescriptive and predictive analytics, which will change the nature of his pipelines.
Yeah, very much. And when it comes to cost governance, there's a need to incorporate that into the design phase for data pipelines and environments, the operation stage, and then the optimization stage as well. You need to predict what the likely cloud costs are. You need to anticipate ways to improve utilization, reduce those costs, avoid unnecessary compute cycles. So there's a real science to it, and it involves a lot of different people wearing different hats. I think the data engineer plays a critical role in making the cloud ops folks smarter, the finance folks smarter, and everything in between.
Yeah, and this move to predictive analytics, I think, wreaks havoc on your pipelines. I'm going to speculate. This is more your area, Kevin, but it seems to me, especially if you put a model into production in a production application, that pipeline has to replicate whatever the data scientist did to create the model and do it in real time and do it reliably, 24/7, 365. That puts a lot of onus on the data engineers and the ML ops engineers to create something that's industrial strength and scalable.
It really does, because once you put something into operation, you need to have high confidence that you are looking at the right features and you're doing the right calculation on those features that you identify within streaming data, and that you have meaningful correlations to data at rest, potentially within a data warehouse or a database. There are a lot of moving parts, and vigilant human oversight assisted by automated monitoring is critical.
Yeah. All right, let's move on to our panel. A lot of good stuff there. A lot of them said that a lot of things these days are just table stakes, like, making sure the data is secure going through these pipelines, that you support lots of sources and lots of targets, so you don't have to, create custom connectors to fill in a gap. Although Nextflow was talking about creating auto connectors, auto creating connectors in its breakout session. I'd love to learn how it's doing that. And then, the full spectrum of low code, no code for, data analysts, data savvy business users, and full code for those who want that. And a combination so that you can switch from one to the other within the same platform. That seems to be table stakes now. Did I miss anything there?
No, I agree. The other interesting dimension that came through in the panel was just how much of a co-opetition landscape it is. I think Mike with StreamSets alluded to it, that they compete in some places and collaborate in others. Data ops helps you manage, among other things, Fivetran ingestion jobs. Fivetran integrates dbt as a native element, and all these environments are looking for ways they can help each other, because they recognize data engineers have a lot of tools and will continue to increase the number of tools despite their best intentions of consolidating.
A lot of talk about data products in the panel. Yeah, and I guess it makes sense. If you're bringing all this data from multiple sources and you can distribute it to multiple targets, well, I guess that's what a data product is. You create something from all these sources, and then if you package it in the proper way with metadata descriptions and ability to be reused and recreated on demand, you can push it to any channel, to any target. And that, I think, in some ways makes that thing at the end of the pipeline a reusable data asset or a data product. I think we're still trying to figure out what the true definition of that is.
We are, and I know, so our colleague Jay is digging in deep on data products and data mesh, and I think I agree with him, if I can paraphrase a little bit, that the data product is probably the most attractive or a starting point for data mesh approaches, because if you can't standardize on modular products that are reusable, have a fixed and reliable set of data and metadata, then everything else becomes more difficult in a mesh scenario.
Yeah, but I would argue, you should be creating data products no matter what the architecture you're using, right? Especially if you to share that across boundaries, whether they're internal boundaries between departments or divisions, or external boundaries with partners, suppliers, customers, or people you don't even know, like in an external marketplace.
And I actually had a good conversation with one of our attendees about just that, and the notion of having sort of a marketplace view of your internal data products, also potentially your external data products, so that various consumers, based on their role, can access and view those. And that was during the Q&A session.
And you know, I'm a fan of data marketplaces, and
Yes.
Nexla did mention that they've got that capability now, and that also piqued my interest. I'm gonna have to dig into that more, see what they're doing there, because I do think, you know, if you're going to create data products, so the next step is publishing those products to anyone who needs them, whether you know them or not, whether they're internal or not. Anyway, let's keep moving on. Well, big focus on Snowflake. No surprise there. I'm, you know, there was also mention of Spark. No mention of Databricks, big competitor to Snowflake. But yeah, that's the dominant data warehousing player, though they don't want to be called that these days, right, Kevin?
The data cloud. They like the term data cloud.
Data cloud, yeah.
And
Okay.
Snowflake likes the term lakehouse. But I think the common construct of SQL queries on top of cloud object storage is where everyone's moving from different directions.
Yeah.
Whatever you call it.
So there's a quotable quote from Mike at StreamSets that shift happens when he was talking about data drift. And their product, evidently, I didn't know this at all, that their product, that's their secret sauce. Like one of their key differentiators, the ability to monitor and manage that data shift that happens, especially when you're supporting predictive applications.
Yeah, and it could relate to infrastructure settings. It can relate to all kinds of things. Drift is a bigger concept and problem than I was aware of before I started working with StreamSets.
Yeah. Oh, okay. We talked a lot about data ops, which is kind of a Uber category in data integration. I think you said it earlier, it's just an umbrella that sits on top of all your data integration products and coordinates them, orchestrates them, helps you change them through CI/CD, helps you ensure quality through test automation. Lots of good stuff there. We just talked about data marketplaces and their value.
Yeah.
And that's all I had. Is there anything else, Kevin, that you came across?
One thing that wasn't explicit in our discussion, but I think implicit, is that because of the nature of the cloud and having open APIs and elastic infrastructure, startups can now go broad out of the gate. The traditional paradigm for a startup would be to focus on a point tool, but there are startups like Rivery that are able to address all four segments of the market: ingestion, transformation, data ops, and orchestration out of the gate. And so that it turns upside down the usual assumptions of what startups are capable of. Now, there are obviously limitations in terms of what a startup can achieve with addressable market initially, but the cloud does kind of lower the barriers in new ways for founders.
Yeah, there was that talk of convergence, right?
Yeah.
And we do have a lot of data management products in the marketplace today, especially in the data integration space. You know, data observability, data catalogs, metadata management. Yeah, lots and lots of stuff here. And you got to think that they can't all survive, I would think. So you're going to have to combine. You know, we've already seen Click take that step, right? It was originally just a BI player, and then it acquired your old company, Attunity.
Yeah.
A few more data companies. And they're trying to be not only end-to-end data platform, but an end-to-end data and analytics platform. And we'll have to see if that's what people want. Or given that these tools today in the cloud are much more interoperable, maybe it's not such a big deal to go best of breed and just plug and play these tools together. Do you have any thoughts or opinions on that?
Well, it seems it'll continue to be a balancing act. On the one hand, organizations over time in tech have tried to standardize and go broad with a suite, but then there's the inevitable need to specialize in certain areas. So I think there'll always be on the margin the need for specialty tools, the new stuff, but over time that gets absorbed into broader suite tools.
Yeah, I do know that CFOs and COOs hate having multiple tools. They want their teams to just go out and buy one tool that does it all, you know, easier to manage, one throat to choke, you know, or hopefully organically integrated. So easier to use, easier to manage, requires fewer people to maintain. but you give up some functionality, obviously. So anyway, I think that's all the key takeaways that I had, Kevin. I don't see any from the.
I think those are the big ones. The one other variable, we didn't answer it and wrestle it to the ground, but ChatGPT and generative AI is starting to become an assistant to data engineers and other types of professionals. And so I predict in 12 months, you'll have some of these platforms integrating with ChatGPT and including AI prompts, create this code, help us debug in this way, that kind of thing. So it'll be a new chapter of automation, hopefully for the better. It'll also create the need for a lot of governance.
Yeah, that's good. I'll add that to this list. Every time I try and touch it, it wants to go to the next slide. But so anyway, we will send you a trip report next week, and then next month, as I said, we'll send you our market landscape report on modern data pipelines. That really is an immersive experience where you get just the highlights from this event in an audio, video, graphic, and text form. So stay on the lookout for that. And our next event, get back here, is Next Generation Data Catalogs on June 21st. We'll go with what's here. And then later this summer in August, we'll talk about data mesh and data fabric. And in December, modern analytics. So hope to see you at those. You can register now for Next Generation Data Catalogs. We hope you do. Hope to see you next time. So thank you all. Thank you, Kevin. And I hope you have a great rest of your day.
Thank you.